we're going to try probability of and events again. I released a video on it last week, and maybe it wasn't the best video. I don't know. So I'm going to try it again. I got a brand new approach, because if I'm going to do it again, I'm not just going to repeat the same thing, which is what you guys should do. If you're not understanding it, don't repeat the same thing. Many of you, most of you, do not reach out if you don't understand something, okay? I know that that's kind of difficult during this time, but you have to, right? Whether that's email, office hours. If you can't make office hours, email me and say, Mr. Taylor, I can meet on Thursday at 2 p.m. I'll make it happen, okay? Don't email me at 1:55 and ask me to be there at 2 p.m. But if you email me in advance, I'll make it happen. We have to communicate better, especially if we're not understanding this stuff. Okay? So, I gave you guys a homework assignment yesterday. And as of the recording of this video, I'm recording about 8:30 at night, maybe 9 o'clock, something like that. And 45 people have turned in yesterday's assignment. You can see right here that the average score is 7 out of 12. So only 1 point above 50%. So not very good. Now, we do have a lot of kids who are getting a 12 out of 12. It looks like about 14 of them. Okay, so, roughly, not 14 out of 45, what would that be? A little less than 25% maybe, something like that. So maybe 20% of the kids are getting a perfect score. So reaching some of you definitely not, though. You can see we got plenty of grades down here. Now also consider 3 of those 12 questions you had a 50-50 shot of getting right, and were the 3 easiest questions. So take away those 3, and all of a sudden now we have a 4 out of 9, which is 44% average. So obviously we have to do way, way, way better than that. So this is my attempt to reteach it. And we'll talk about how we'll move forward from this video. Okay, the homework. Okay, Wednesday's homework. Judging by these results, I'm going to guess that these people down here don't want this grade to go in the grade book. These people over here are probably cool with it. These people aren't, or at least they shouldn't be if they are, especially this kind of group down in here. So what I'm going to do is have you do something, which is watch this video. Now, obviously, if you're listening to me right now, you're watching the video. However, if you're just looking at the slides, then you're not watching the video. So, first thing, watch the video, try to get a better understanding. Make sure you do Wednesday's homework first. Okay, do not do today's homework, do Wednesday's homework. This is huge. If you are still confused, first of all, that's okay. Welcome to math. If you're confused, you're normal. It's okay. If you're confused, then attend office hours or set up a meeting with me. All right? It's not like I'm going to make you stay on your camera for an hour and a half, all right, whatever. Just pop in, spend 5-10 minutes, ask a question, and we'll move on from there. What I'm going to do, if you'll do these things, what I'll do is look at Wednesday's homework, look at Thursday's homework, and I'll take the better of the 2 grades. The questions on Wednesday's and Thursday's homework are the exact same questions. Okay, I didn't even change them. Right? That way you get a chance to be retaught, and then you get a chance to redo that assignment, and you'll get the better grade. Okay, so let's look here. Independent versus dependent. Okay, now we have to understand independent versus dependent in order to know how to do the probability of and events. So I'm going to set up a scenario. Okay, I have a deck of cards in my hand right here. I don't know how high I am here. And you can see hopefully that it's just a normal deck of cards. For those of you who don't know much about cards, there are 52 cards in the deck, and none of them are the same. Okay, now, for example, there are 4 aces. Okay, I have 4 aces right here. but I have an ace of diamonds, an ace of spades, an ace of hearts, and an ace of clubs. Okay, so it's true there are 4 aces, but there are 4 unique aces. So there are not any 2 cards that are the exact same in a deck of cards. So what we're going to do is we're going to find the probability of drawing the King of Hearts first. Right, the King of Hearts is this card. And then we want to know what's the probability of getting the Ace of Spades, which is this card. So we're going to find the probability that if I just say, hey, draw a card, you first draw the King of Hearts, and then second you draw the Ace of Spades. We want to find the probability of that event happening. So, the first time I do this, right, so I put scenario 1 up here. The card is replaced. Okay, so right now, we are going to find, well, first of all, we're going to find my marker. That'll be what we do first. Well, here's one. All right, so the first thing we're going to do is set up our problem. So I want to know the probability of the King of Hearts and the Ace of Spades. Some of you are finding the probability of this and the probability of this and adding. Okay, if you watched that first video, which I'm not convinced a lot of you did, right? I don't think some of us aren't watching the videos. It's pretty easy to tell when 45 kids turn in an assignment and the video from the same day only has 32 views, so that obviously doesn't add up. But anyway, that says and, a lot of you are adding. You do not add when it says and. You add when it says or. When it says and, you multiply. Okay? Now, we have to figure out, first of all, if this is independent or dependent. Independent means if on the very first time I draw a card, okay, and I get the King of Hearts, like I just did there, and I put the King of Hearts back in the deck, does the probability that I draw the Ace of Spades change? In other words, by itself, what's the probability of getting the Ace of Spades? It's 1 out of 52. Okay? If I successfully draw the King of Hearts, put it back in the deck of cards, is the probability of getting an Ace of Spades still 1 out of 52? And if you say yes, that means the probability did not change. Therefore, they are independent events. Okay? One happening does not change the probability of the other happening. Okay? So I just drew my King of Hearts. I put it back in the deck. And now I'm going to draw another card. And it's going to be the Ace of Spades. Okay? I want to find the probability that happens. So I'm going to take the probability of the King of Hearts and then take that times the probability of the Ace of Spades. Well, the probability of getting the King of Hearts is 1 out of 52 times, now, when I put the King of Hearts back in the deck after I have drawn it out, there are again 52 cards in this deck, so the probability that I get the Ace of Spades is still 1 out of 52. So this is an independent event, and I'll take 1 over 52 times 1 over 52, and that gives me 1 over, thank God for calculators, 52 times 52, 1 over 2,704. So that's the probability. So the probability that if I say, hey, here's a deck of cards, you first draw the King of Hearts, and then you put it back in the deck, and then second draw the Ace of Spades, That'll happen 1 out of every 2,704 times. Now, let's instead look at the second scenario. In the second scenario, I'm still wanting to find the probability of first getting the king of hearts and second getting the ace of spades, but this time the cards are not going to be replaced. Okay? So we still have the probability of king of hearts and ace of spades. That's still what we're looking for. We are still going to take the probability of first drawing the king of hearts times the probability of getting the ace of spades. But this time, after I randomly draw from the deck and I get the king of hearts, instead of putting the king of hearts back in the deck, I'm not going to. So now I have not 52 cards, I have 51 cards. Okay, that first event happening did change the probability of getting the ace of spades. Okay, if you look back at the last slide, the probability of getting the ace of spades was 1 out of 52. The king was drawn, thrown out, and now I only have 51 cards left. So the probability of getting that king of hearts was 1 out of 52, but now the probability of randomly drawing and getting the ace of spades is going to be not 1 out of 52 because the king of hearts is gone. It's 1 out of 51. So take 1/52nd times 1/51st, and I get 1 over 52 times 51. So that's 1 out of 2,652. And they are dependent. Okay, the probability of this one depends on this event happening. When that event happens, when I draw the king of hearts, it changes the probability of what the ace of spades would be. Because if I just asked you to draw a card and say, what's the probability of picking the ace of spades, it would be 1 out of 52. But if I first draw the king of hearts and I don't put it back in the deck, that changed to 1 out of 51. That's what it means to be dependent. We still just multiply, but this probability changed. When it was independent and I did replace the card, this said 1 out of 52. When it was dependent and I did not replace the card, it was 1 out of 51. Okay? So hopefully that clears up independent and dependent. Our answers on that were pretty strong. Okay, 85 to 90% of us got those 3 questions right. Okay, on your homework on 1 through 4, instead of having an 8-sided die, instead of having a 6-sided die like we have here, you have an 8-sided. And you have a spinner, but instead of having letters, it has different colors and it has numbers. So these aren't going to be exactly like your homework questions, but they're going to be very, very, very close. So the directions say a 6-sided die is rolled 1 time and a spinner is spun 1 time. Find the probability of the given events. So, is this independent or dependent? Okay. Ask yourself, if I roll anything on this 6-sided die, does it change the probability of what I land on when I spin the spinner? In other words, if I roll a 1, does it change the probability that I land on B? It shouldn't change it at all. What happens on this 6-sided die will not change any of the probabilities of what happens on the spinner. So these are independent events. Right. So up the top, it says, what's the probability of rolling a 4 and spinning a C. Okay, so I want probability of a 4 and a C. So, and means you multiply. So we have probability of 4 times the probability of C. The probability that I get a 4, well, there's only one 4 on a 6-sided die, so that probability is 1 out of 6 times, okay, there's 1 C, there's 2 C's, so times 2 out of 8. Now, 2/8 reduces to 1/4. So now I have 1/6 times 1/4, and I get 1/24. So that's the probability of rolling a 6 and spinning a C. Okay. What's the probability of rolling a prime number and spinning a vowel? So your sample space for this 6-sided die, 1, 2, 3, 4, 5, 6. 2 is prime, 3 is prime, and 5 is prime. 1 isn't, 4 isn't, and 6 isn't. Okay, so probability of prime and a vowel. So that's going to be the probability of prime times the probability of a vowel. Well, 3 out of 6 is your probability for rolling a prime number. And the probability that you land on a vowel, well, that's 1, 2, 3, 4. A and E are all vowels. C, B, and D are not. So that's 4 out of 8. 3 out of 6 reduces to 1/2. 4 out of 8 also reduces to 1/2. So we're taking a half times a half, and we get 1/4. So the probability is 1/4 of doing both of those things. Rolling a prime number and landing on a vowel. Okay. Hopefully that helps you with the first 4 from the homework. If it doesn't, see me in office hours. Ask questions. Okay. This will help us with examples from 5 through 8. Now, I don't remember exactly what the marble count is, but it's something like this. You have a bowl of marbles, and there's so many of red ones and blue ones and green ones and all that other kind of stuff. This bag happens to have 4 green, 2 blue, 3 red, and 1 yellow marble, which means there's a total of 10 marbles in the bag. Marbles are picked one at a time and are replaced after each marble is picked. Find the probability of each given event. So we have to figure out whether this is independent or dependent here. So think about this. If I want to find out the probability of picking a blue marble, that would be 1, 2 out of 10. So I take that blue marble, look at it, put it back in the bag. Did the probability of getting a green, yellow, or red change? No. It's still, red would still be 3 out of 10. Yellow would still be 1 out of 10. Green would be 4 out of 10. All right? If I pick a marble, put it back in the bag, the next time I go to draw a marble, the probability for each of those remains the same. Okay? So right now, the probability of yellow is 1 out of 10. The probability of blue is 2 out of 10. The probability of red is 3 out of 10. That's a pretty sad looking R. Is 3 out of 10. And the probability of green is 4 out of 10. So if I reach into that bag and I draw the yellow marble, put it back in the bag, the probability of blue is still 2 out of 10. The probability of red is still 3 out of 10. The probability of green is still 4 out of 10. The second time I draw a marble, those probabilities don't change. So if I do the first event and the probability of the second event does not change, these are independent. So let's look at the first example. I want to know what is the probability of picking a red and then picking a blue. So I'm looking for the probability of red and blue. That's going to be the probability of red times the probability of blue. Okay, so I reach in the bag, I pick this yellow or this red marble right here. The probability of doing that was 3 out of 10. Look at it, say, hey, I got a red one. I put it back in the bag, so now all 10 of them are still available, and the probability that I get a blue is 2 out of 10. 2 out of 10 reduces to 1 out of 5. Multiply straight across, and I get 3 out of 50. So the probability of that event happening is 3 out of 50. What's the probability of first picking a green and second picking another green? So I want to know what's the probability of green and green. Well, that's going to be the probability of green times the probability of green. Okay. I'm going to reach in the bag. The probability that the first marble I get is green is 4 out of 10. I'm going to put that marble back in the bag. So the probability that I get another green, since it has not changed at all, every marble is put back in, is also 4 out of 10. Okay, that's going to reduce to 2 out of 5. That's going to reduce to 2 out of 5. Multiply straight across, and we get 4 25ths. So the probability of that event happening would be 4 out of 25 times. Okay, so you have to look real close, because on this slide, you can kind of tell it shifts a little bit. I changed one word. I added this word right here where it says not. So we still have 4 green, 2 blue, 3 red, and 1 yellow. This time though, it says marbles are picked 1 at a time and are not replaced after each marble is picked. Find the probability of the given event. So it's almost like the last scenario, except when I pick the marble out, I do not put it back in the bag. That's going to change everything. Are these independent or dependent? Okay, so let's say I want to find the probability of blue and blue. The first time I draw a blue marble, it's going to be 2 out of 10, right? But this blue marble is now gone. I did not put it back in the bag. The probability of this blue marble is not 2 out of 10, just like this one was. There's 1 less blue marble in there. 1 of them is blue. There's 9 total. So now the probability of blue changed from 2 out of 10 to 1 out of 9. That first event happening caused the probability of the second event to change. That is called dependent. So let's go through. These are going to be the exact same questions, but because we're not putting the marble back, we're going to get different answers, okay? So we're going to do this one again. Picking a red and then picking a blue. It's going to look the same until we put numbers on it. So the probability of red and blue, it's going to be the probability of red, can't make R's today, times the probability of blue. The probability of red is 3 out of 10, just like it was last time, because it's the first thing we're drawing. But our red marble is gone. Okay, this one's no longer there. So now we only have 9 marbles left, 2 of which are blue. So the probability, instead of being 2 out of 10 like it was last time, because we put the marble back, is 2 out of 9. Okay. Now, when you multiply fractions, you can reduce any numerator with any denominator. So 3 goes into itself once, and it goes into 9 3 times. 2 goes into itself once, and it goes into 10 5 times. So the probability is 1/15. That's a really bad looking 3 there. So the probability is 1 out of 15 times. All right, let's look at the second one here. The probability of green and green. So that's going to be the probability of green and green. So probability of green times the probability of green. I reach into the bag, I pick out a green marble. The probability of that was 4 out of 10. So now this green marble is gone. I'm down to 9 marbles, and I no longer have 4 green, I only have 3 green. So that's going to be 3 out of 9. That reduces to 2/5. That reduces to 1/3. And I get 2 out of 15. So the probability of that event happening is 2 out of 15 times. Okay, if you need help, then ask. All right, don't settle for not understanding. Again, office hours, I'm available at least an hour every Tuesday, Wednesday, Thursday. If you need me after office hours, just send me an email and set up a time. Okay, you have to communicate that though. I can't call all of you at home and be like, hey, do you have any questions? That's going to be impossible. You have to reach out. If you reach out, I can make it happen. If you don't, it's nearly impossible for it to happen. That bit is on you guys. All right, hopefully this assignment goes better. If you're in the middle of it and you're not real sure, just ask a question. See you guys.